Welcome guys. We are getting into properties of hyperbolas. So last time we talked about ellipses. For this one, we're kind of dealing with similar properties. If you notice, that's the title of this IXL. So what pieces make up a hyperbola? And if you notice, we have this like kind of reversed U shape here. That's what we're dealing with. That's what a hyperbola is. Basically a constant distance away from 2 points, kind of like an ellipse, just kind of reversed. But we're more focused on the properties at the moment. So we're going to be talking about kind of the equations that make up a hyperbola, the vertices, a transverse axis. I believe they call it a conjugate axis as well, something a little bit different. Possibly asymptotes and just other pieces of the graph. Alright, so I'm going to try to take some of your guys' recommendations and work through a few extra examples. But be sure to leave a like if this helps. We're trying to get to 200 subs as well. And hopefully the extra clarity does make this a little bit more useful. Okay, so the first thing that this asks for are the vertices. We did mention that we have kind of this hyperbola where they open up and down. We'll also see there's going to be options where the graph itself, kind of like those U-shaped pieces, are on the sides, and it's going to kind of affect what we have. For the vertices, if it is up and down like this, the x values are going to be 0 in our coordinates, because the vertices are actually kind of our minimum of one and our maximum of the other. So this is nice, it gives you the visual. If we had the equation, it would be 0 and positive and negative a, which we'll talk about what a is when we get more into the later portions of this IXL with the equation, but it's similar to the ellipses properties that we did. Okay, we actually see the 2 points here, so this one's hopefully not too difficult. We know that we have 0 and positive 2 and 0 and negative 2. So just one more time to recap. It's kind of the minimum of the one is how you can think about it, and the maximum of the other. So let's make sure we're all good there. There we go. So let's clear that one off. This is what I was talking about before. You could see it on the left and the right sides as well. These dashed lines in the kind of purple color here are asymptotes. So these actually aren't part of our graph. They actually just kind of help shape our graph, because we can get infinitely close to those dotted or dashed lines but never cross them. Okay, this one asks for the center this time. So if you don't see where these asymptotes cross being shifted left, right, up, or down at all, it means the center is just at 0, 0. So it's kind of wherever these cross. So this one's not too terrible. Kind of like the last one. They cross at 0, 0. That's how we know. If it was shifted at all, you would be able to tell based on where they're crossing. Okay, so this time we want to know about the length of the transverse axis. So they use actually two different terms relative to what the book for my class uses, but this one is similar to the book. The transverse axis is based on if these U-shapes are up and down like this or side to side. If they're up and down, it's going to be a line like this. Hopefully you guys can see that there. Maybe we can do a little bit bigger. There we go. If they were side to side, it would just be like this way instead, but we don't have that here. It's basically the distance, since it's length, from one vertice to the other, or one like vertex to the other, since it's plural. So from 2 to negative 2, if that doesn't pop into your head right away, you could count 1, 2, 3, 4. Okay, my length from one to the other is 4. So that's what it means by transverse axis. It's that distance there. Okay, so the conjugate axis, this is the one that gave me the most trouble kind of starting to think about this. Because our book doesn't use this term, but it does talk about it. It just doesn't give it a name like this. So we're looking for the length of the conjugate axis. The best way I can explain this was when I used this web paint tool and I took the rectangle and I went from kind of where my asymptote crosses the grid right here, and I drag it so that the corners, let's use the arrow, the corners are all, oops, before I get explaining, I actually made that a little too big. Let's try this one more time. There we go. Okay, so now what I was about to say. The corners are all on the grid. The line of this rectangle right here is tangent to this vertex, meaning they basically just touch one time and it keeps on going, and same thing over here. You notice if I put a line from one side of this rectangle to the other, that would give me the transverse axis, so from one vertex to the other. However, what we want here, let's try to change colors, something noticeable, is this kind of opposite axis. So this would be the transverse axis. This would be the conjugate, the one that is kind of going the opposite direction, the one that doesn't touch the vertices. How long is this? This is from 2 to -2 again, so that one's actually 4. My suggestion, if you have the capability, and I know this doesn't work for everybody, if you can look for this web paint tool or anything similar that lets you draw on your page and add that on here and actually make this rectangle. I had that stereotypical light bulb moment when I drew this, and I'm like, oh my gosh, this makes so much sense. If you have the Precalculus book with you or something like this, and you're going through the 11.3 section on hyperbolas, it actually shows it with a rectangle in there. They call it the central box. It just makes this axis, what the vertices are. It lands right on each of these corners. It makes it so much more obvious, I think, what's going on here. So I highly suggest that. But if you didn't have this, let's rewind just a second. If you didn't have this, another way to find it kind of quickly, I guess, that's kind of the why, is I would look at, on either side, wherever it hits the grid, and wherever it hits the grid again, to where you go along this vertex, it's that distance. So again, that would be 4 in this case. I'll hopefully be able to explain that another time for you guys. Okay. Transverse axis, this is kind of the easier one we said. Let's go back up to 20% on the size there. Transverse is a little bit easier to just see without any extra drawings. It's from one vertice to the other. Remember, the vertice is kind of these turnaround points where they dip in and go back out, or like a maximum and a minimum on their side. And because we want length, it's actually this distance right here. If you notice, this kind of crossing part of the asymptote is scooted over from 0. So we might actually want to count those boxes now. So if we go over, we go 1, 2, 3, 4, 5, 6 is our length. So that's what we would put in here. Okay, so this time we're doing conjugate axis again. This is where I suggested that rectangle. I'm actually going to draw that again to hopefully make sense of kind of what I'm talking about. Let's go back to black for this. and the rectangle. Remember, we want the side of the rectangle to just touch this vertex once and just touch this vertex once. So I'm going to take it where it crosses the grid, where the asymptote crosses the grid, and down to the opposite corner where that happens. And if I draw it perfectly, it just touches once and once. And then, again, this would be the transverse axis from one vertex to the other. That's kind of the more obvious one. The conjugate axis, and I definitely suggest kind of playing this back as you're working through, is the other part. The one that doesn't touch the vertexes, or the vertices. So that'd be across here. So from -3, it looks like, to 3, and that would tell me that length is 6. Again, I'll try to show it without the box in case you don't have that capability. Think of just a line, maybe, if nothing else, that goes from where... How about this? This might make more sense if you can't draw on your screen or have anything like that. Maybe you want to draw it out. That might be the best. I would pick one vertex and go how many boxes on one direction until I hit the asymptote, how many boxes in the other direction until you hit the asymptote, and count all those. So 1, 2, 3, 4, 5, 6. That might make sense of it, and you would get the same thing here as well. Okay, so let's bring that back. There we go. 6 should work here. Terrific. What are its asymptotes? Okay. For this one, we're putting in equations, I believe. Point slope form. Okay, that's a little bit different from the book. So I think I'm gonna try it like the book tells me, because if so, that can be more beneficial to you guys. So anyways, we would think about like the slope of this line. So maybe if we're starting at 0 and I want to go until I get to the vertex and then over. So I would go up 5 and over 4. So maybe let's write this out. Y equals mx plus b is kind of what we're thinking about right now in terms of the equation of a line. I don't have a b value this time because I start on 0, so I don't have to even show that. My slope is 5 over 4. Because I go up 5 and over 4, I'm going to see if it just lets me take that, not have to put any like zeros in or anything like that. So I'm going to use this to make my fraction. We're kind of learning together here. The nice thing is the other one's just going to be the negative version because it has to go down and over the same amount. So this one's going to be y equals negative and then 5 over 4. We'll just see if IXL takes this form. So to recap real quick before I type that in case it does count it, and if not, we'll definitely want to go back to one of these. I saw starts at 0, so that's why I don't have any like plus b on there. I think if I did have the plus b, I would be more inclined to move it into this form right here, point slope form. I found my slope by counting up and over, and then because this one just crosses directly through it, it's just going to be the negative version. Okay, awesome, it took it just like that. Okay, so I think that's going to be the way to go there. And I wouldn't worry about moving stuff around. Technically, it is point slope form when we don't have like a 0, or when we don't have a y-intercept there and it is 0. So maybe we'll go back and find another one if it pops up. Alright, we're looking for vertices again. Let's change colors. Remember that the vertices are kind of the minimums or maximums, or if it's on its side like this, the turning points. So I'm just asked for those coordinates. In this case, both y values are 0. If you notice, they're not up or down at all. But one is -5, 0, and the other is at 5, 0. So I'm just counting coordinates here. Okay, we finally get to an equation. So I want the length of the conjugate axis. So I would say first we want to find the transverse axis, or kind of think about our A and B. So let me put it this way. Let's do some drawing on the screen here. Last time with the ellipses I started in Desmos, and that might have been the way to go here. So we have two options again for formulas. We have x squared over a squared. It's going to take me a minute to write out, but that's okay. I'll let you guys catch up maybe. Y squared over b squared equals 1. We have another option where the x and the y are basically flipped around. So the y would be first over a squared, and then the x would be second. And without a stylus, this is a little difficult, but we're getting there, equals 1. Okay. So now we have to think about which one we have. We have the one that has y first. So that means we're using this version. When we're looking for the transverse and conjugate axis here, the transverse is 2 times A, and I'll try to label this in a second. The conjugate would be 2 times B. That is actually true for the other version as well, as long as they don't ask us to clarify if it's horizontal or vertical. For this one's vertical, so let's actually start labeling. This would be a vertical, and then transverse. This would be, move down a little bit, horizontal, and that would be conjugate. If we were dealing with this one, we would have 2 times A again. Let's go ahead while we're here and draw it out. 2 times A, 2 times B. So similar, this would be horizontal, and transverse. This one would be vertical, so that's the part that flips. Okay, so maybe this is the thing to take a screenshot of or something like this to make sense of it. Okay, so back to our problem at hand. We said we have this version because our y comes first. We want the conjugate, so we're looking for 2 times b, so we need to think about what b is. If this is 16, we need to think about what squared gives me 16. So in our case, we're going to have b is 4. Kind of think about it as, let's see if I can go one size smaller. This would be like 3, oops, the zoom in part doesn't work. This would be like writing 3 squared and 4 squared. So that's where I'm getting A and B from. So B is 4. So 2 times 4 would give me 8. Finally, I would be able to figure out that the length of the conjugate axis is 8. So definitely want to go and kind of have this pulled up as you're working through. Maybe we'll timestamp this part as well. Okay. The foci. So that's kind of like the ellipse. It's part of the... It's not actually on the hyperbola itself, however it determines the shape of it and kind of how wide those U shapes are. When we have the x first, let's actually write this out again as well. So I'm going to say if the x is first and if the y is first, so it's going to save me some writing. If the x is first, our foci coordinates are going to look like this, plus and minus c, and we'll talk about where c comes from, and then 0. Oops. Apparently I'm looking up something in the dictionary. If y is first, it's not in this case, but just in case you run into an example like that, we're going to have plus and minus c as the y coordinate. Now how to get c, this is going to be the same for each. It's going to be kind of like Pythagorean theorem. C squared equals a squared plus b squared. So I need to think about, let's rewrite that real quick. That's a little bit better. I need to think about my a and b values here. My a value would be the square root of this is 8. However, in my formula, I'm just going to square it again, so it would just become 64 again. 36, that would be 6. But again, in my formula, I'm just going to square it again, so I might as well just use the 36. So if I plug these in here, I would have 64 plus 36 equals c squared. Those add together to be a 100, so c squared equals 100. I think most of the time it's going to work out to where it's a perfect square, where it's going to give you like a whole number. Square root both sides, I would get c equals 10. So then I would be able to take that c value. I would say, okay, x comes first, so I'm using this one. So I'm going to have a positive 10 and 0 and a negative 10 and 0. Perfect. And if it was y first, you would use this one on the right. Okay, we're almost to that 70 score. What are the asymptotes? Okay, so for the asymptotes, we have two different formulas again based on if x or y is first. We'll kind of set that up similar to what we were doing before. If x is first, right here. If y is first, right here. If x comes first, so similar to what we have in this problem, we're going to have y equals, and then we're going to have both plus and minus. If you remember from when we were given the picture, we had two asymptotes that crossed each other. And we're going to have b over a, and then x, which we're not going to fill in, just going to fill in the b and the a from these. So remember, a squared and b squared, so this is going to be 12 squared is the same thing as 144. You can't see that very well. 25 is the same thing as 5 squared. So our a is 12 and our b is 5. Now if you had y up front, which we don't in this case, but you could, very similar, you're still going to have y equals, still going to be plus or minus. However, the a is going to be on top and the b is going to be on bottom. That's the only difference. Those two things flip-flop. and then still times x, which doesn't get filled in. Okay, so in this one, our a is 12, our b is 5. X is first, so we're using this one. So y equals, let's do the positive one first. B is 5, A is 12 times X. I'm actually just going to copy and paste here. You could retype it if you wanted. The second one is the same exact thing except negative. So they should look pretty similar. Super. Okay, let's keep going, maybe one or two more, even though we're at that 70 score that I've been asking for now. The center is going to be based on if you have anything added or subtracted with the x or the y, and it's kind of like the ellipse. It's just the opposite of kind of what you would expect. There's nothing added or subtracted up here, so this one's just going to be 0, 0. Nothing changes. Let's actually, since we're well past that score now, we're a full problem pass. Transverse axis is something we've already talked about too. Let's go back to the beginning and see if there's anything that we need to talk about one more time. Okay, the center we said is just where they cross, so this would be 0, 0. If it was shifted, we would just put that coordinate in. The asymptotes, okay, so that's just where we found the slope. So this would be like up 4 over 3, and we would put like y equals 4 over 3x and y equals negative 4 over 3x, because we also would have to go down and over for this one. Okay, that's something we talked about. I just want to make sure I didn't miss anything. The center, okay, doesn't get shifted at all. 0, 0. And the asymptotes we just covered. Okay, so I think we've touched on everything. I'm definitely going to encourage that if you watch this and it was helpful, to please leave a like. And if there are things that popped up when, like if you're in my class and you're working through this and it's something I didn't cover, let me know. I'll either explain it in the comments, I'll explain it directly to you, or if it's something that's a common issue, I'll re-record something else or something additional and I'll upload that too. So don't be afraid to reach out. I definitely want to make sure you guys get what you need for this type of knowledge. Alright, so this is P10. If you're in my class, we'll have that assigned. Hopefully it helps. Thank you guys. We'll see you.